Hi dear students, I hope all of you are doing good. So welcome to another important session of Brainiacs Capsule. So today we are going to discuss a very important topic that is expected for Neet. Very important topic. Can you tell what it is? So it is regarding electrophilic addition reaction. So we know that organic compounds will give a lot different types of reactions like electrophilic addition, nucleophilic addition, free radical addition, nucleophilic substitution, electrophilic substitution, okay, elimination reactions. So in that we are going to discuss the concept of electrophilic addition in detail and the most important or the expected questions for NEET 2024. Okay. So the first question in front of you here is, all of you could see. Yeah, please read along with me. That will give you confidence. So the question here is 3-phenyl-propene on reaction with HBr gives which of the following as the major product? Okay. So first challenge is we need to draw 3-phenyl-propene. Next we need to know how HBr react with this. Okay, so before going to that, I will give you a rough idea of electrophilic addition reaction. Okay, so I can say electrophilic addition reaction, EAR, means electrophilic addition reaction. It is given by alkenes, they give electrophilic addition reaction. And I am going to explain why it is like that. Okay, so if you know this concept, you will be able to easily say whenever a compound is given, whether it will undergo what type of reaction. I can easily say that. Okay, now if you listen here, I have taken an alkene, CH2 double bond CH2. So this is called, what name sir? This is called ethene. All of you might be knowing this compound, ethene. Now, what I am telling here is, if you analyze this ethene, we can say that this ethene has pi bond present. Now we know that the pi bond is a weak bond actually. Okay, weak bond means it can easily undergo polarization. Polarization means it can easily shift either towards right or it can shift towards left. Okay, now what this pi bond will do? The presence of pi bond here means there are pi electrons are there. So that will create a negative field here. So you can see here I have shown here negative charge or a minus circle here. So that indicates my field of negative charge. Why I am showing minus all over here? It indicates that the whole together the molecule has a negative field to outside. Okay. Why it is like that? Because of the presence of pi bond. Now I can easily say if a negative field is present around the compound, surely who will come near to that? I can say oppositely charged species will come near to that. So in organic chemistry we know that the oppositely charged means opposite of negative is positive. So positively charged attacking reagent is called my electrophile. So I can say this is my attacking reagent. Okay, so this is my attacking reagent. Okay, this is my attacking reagent. Clear? So there are different types of attacking reagent. You are learning that electrophile, nucleophile, free radical, like that. So here, why the electrophile will approach near to that? Because of the pi electrons. This compound, if you have pi bond in a compound, fundamentally that will have a negative charge surrounding that. Okay, so because of that negative charge or negative field around that, who will approach? You can see electrophile will try to come near that pi electrons. Why? Because there is Coulombic force of attraction. Because positive charge here and pi electrons have negative charge, and because of that Q1 Q2 we know that F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. So there is a great tendency of electrophile coming near to the pi bond. Okay, now we know that always unsaturated compounds, like unsaturated compounds are those compounds which have pi bond in them. They usually gives 95% they gives addition reaction. Addition means conversion of this pi bond to single bond, or we can say unsaturated compound gets converted to saturated compound during an addition. Addition means what actually? Adding anything to the existing pi bond. Why the pi bond is giving addition? Because the pi bond can undergo polarization in the presence of this attacking reagent. What is polarization? This entire pi bond will shift towards one of the atom. So pi bond shifting towards the one of the atom means this pi electrons are moving to one of the atom. So it would be represented as a negative charge here. So what will happen to the other carbon? It is losing 2 electrons. So that will be represented as a positive charge here. So this phenomenon of polarization of a pi bond in the presence of an attacking reagent is known as electromeric effect. Why it is called a temporary effect? Only when the electrophile approaches the pi bond will show this polarization. That is why it is called a temporary effect. Okay. Now we will see how this happens. Okay, so I told our electrophile is approaching the pi bond. When it has approached, what happens to the pi bond? The pi bond that was present here immediately moved to this particular carbon atom. Now you can ask me, sir, why it is not moving to this carbon atom? Because here the alkene I have taken here is symmetrical. So if it moves to here or if it moves to here, it is irrelevant. Okay, because it is symmetrical. Now we are assuming it is moved to the right side. Now what is happening? A negative charge will come here. Why? Because of the 2 pi electrons coming here, and it has lost 2 pi electrons, so that a positive charge coming here. Now the electrophile E plus, and we know that it will approach the negative charge because of the Coulombic attraction. So it will come here, and it will, what happens? This pair of electrons will move to the vacant orbitals of the electrophile, and a bond will be formed. Okay, now you can say that this is called an intermediate. Why it is called an intermediate? Because this is somewhat stable. This type of intermediate with the carbon carrying the positive charge is called a carbocation. So please understand, this first step that I have mentioned here is a very slow step. It will take time for this to happen. Okay, so once this carbocation is formed, it will stay in the reaction medium. Why it is staying? It is waiting for the oppositely charged species, because now the positive charge needs to be attacked by someone which is having opposite charge. That is, I can say, nucleophile. Nucleophile is an attacking species which carries negative charge or a pair of electrons. So what it will do? It will donate its pair of electrons to the vacant orbitals of carbon and forms a bond like this and forms the final product. Now we can say that if you see the mechanism of this electrophilic addition, now what is happened at the end of the day? At the end of the day, I can say that the double bond is disappeared and 2 attacking reagents gets added. That's why it's called addition, added to the both side of the carbon. Okay. Now, if you see this mechanism of electrophilic addition reaction, you can notice one thing. There is one step, this is the first step, and this is the second step. We know that we learned in kinetics that whenever a reaction happens in multiple steps, the slowest step determines the rate. So I can say that this is my RDS or rate determining step. So that means, what does that mean actually? That is most important. That means how fast the reaction completes, how fast the reactant will become product depend only on the first step. Depends only on the first step. It does not depend upon the what step? The second step. Why? Because the second step is a very fast step. Why? Why again it is called as a fast step? Can anybody tell? I can easily say the reason is you have a negative charge here, anion, and you have a cation here. We know that anions and cations will attract very fast. And I can say the second step is almost have what nature? Ionic nature. Or I can say it is almost like an ionic reaction. And we know that ionic reactions are very fast reactions. Correct? So I can say how fast this reactant will become product depends only on the first step. So I can say that whenever there is a comparison is there, what you need to check? You need to check how fast the reactant can become a stable carbocation. So if it is a stable carbocation only, the first step will complete very fast and becomes a stable carbocation. I know that it is a slow step, but if you are comparing maybe 4 different reactions, I need to check whichever of the following 4 reactant can form a stable carbocation. Whoever is able to form a stable carbocation, it will proceed to that step very fast, comparing the other ones. But comparatively, these reactions becoming a carbocation is a slow step. Okay, I hope you understood. Now I have represented this pictorially. So you have the reactant. So the reactant is attacked by the first attacking reagent. We know that usually if this reactant contains a pi bond, it will be attacked by electrophile, and this is the slowest step, and that is my rate determining step. And it forms the reaction intermediate. Then what will happen? This reaction intermediate is further attacked by the nucleophile, and it is a very fast step and forms the desired product. This is the fundamental mechanism with which electrophilic addition reaction occurs. But here you need to take care one very important point. That is, whenever we know that always the reaction intermediate in a electrophilic addition reaction is whom? We know that that is carbocation. Correct? So carbon with the positive charge. So here what you need to ensure here is the carbocation formed should have always carbocation have a tendency to undergo rearrangement. There are different types of rearrangement like hydride shift, methylide shift, and benzyl shift. Like that, different shifts are there. I will explain that in our next videos. So when if it has a possibility to why it is undergoing shifting to become a more stable carbocation. Understood? So if there is a possibility of shift, try to do that particular shift and check whether it forms a more stable carbocation compared to the previous one. In that case, that stable carbocation will get attacked by the nucleophile and forms a product. Okay, if you forget the step of rearrangement, what will happen, sir? You will get a wrong product. Very, very important. Okay. Now I am taking our question. Now I hope you understood. Now we have, this is our 1-phenyl propene. So no, sorry, 3-phenyl propene. Why it is called 3-phenyl propene? This is number 1, this is 2, this is 3. Okay, and here the phenyl group is behaving like a substituent. That is the reason why numbering comes from left to right. So this is my 3-phenyl propanene. Now what is happening here also? If you see, analyze, you have pi bond present. Super. And you also have pi bond in where? In benzene. Now students may ask a question, sir, here the electrophile HBr, we know that HBr, how it will undergo bond breakage. All of you can see here. Now if you see HBr, bromine is electron negative, so electrons will stay near to bromine atom. So when the bond undergoes breakage, the negative charge will go with the bromine and forms Br minus like this, and H plus will be formed. H plus will be my electrophile. And please understand, this type of fission is called heterolytic bond fission. Why it is called heterolytic? Because you are getting different species after the bond breakage, anion and cation. In a homolytic fission, each of the electron goes to each of the atoms. Okay. Now I can say who will approach this compound very fast. I can easily now say there are pi electrons here. Here also there are pi electrons, pi electrons. So altogether this compound has what field? Negative field. So surely electrophile will come. Now comes the biggest question. Sir, what happens? Why it is going to this pi electron, sir? Why can't it go to benzene? Sir, there is no difference, sir, because in benzene the pi bonds, they are in resonance. It is not localized at a one particular place. That is the reason why even though pi bond is present in a benzene, it normally will not undergo addition reaction, because when H plus is trying to go and add to the benzene, this pi bond is moving like a fan. Okay, because there is a phenomenon called resonance. So it will come to here, then from there it will come like this, then it will go like this. So there is no localization. So very important condition for addition reaction is the pi bond should be present. It should be localized at a particular spot. Then it is easy for addition to happen. So I can say H plus will approach this pi bond which is localized, because there is no resonance here. Double bond, here single bond, again single bond. So there is no conjugation. So what will happen, sir? So when H plus approaches this pi bond, the pi bond will show polarization, or we can say electromeric effect. Because of that, it has a tendency either to go towards right or it has a tendency to go towards left. Now students ask me a question. Sir, this compound is not symmetrical. So we will get different possibilities if it go towards right or if it go towards left. So how we can say, sir, whether it goes towards right or towards left? Yes, sir, I understood your doubt. But what you need to do, you draw out two possibilities. So I have drawn both possibilities. So when it is going towards the right, you will get this particular species. When it is going towards the left, you will get this particular species. Why? Because when pi bond goes towards the left, both electrons are coming here. Correct? Now what you need to do? Now you need to analyze which among the following two species is more stable. How you can do that, sir? There are different phenomena: resonance, hyperconjugation, inductive effect. You can see here this type of carbocation, the carbon is connected to two other carbon atoms. So I can say it's a 2-degree carbocation, sir. But here if you see, this carbon is connected to, positive charge carbon is connected to only one carbon atom. So it's a 1-degree carbocation. Correct? We already know in our fundamentals that always tertiary carbocation is more stable than secondary, which is more stable than primary. Using that, you can immediately arrive at a conclusion. Okay, if you don't know that, what you need to do? You consider hyperconjugation here because there is no resonance present. So next you need to consider hyperconjugation. So in hyperconjugation, what we will check, sir? The carbon atom with the positive charge is this one. So the nearby carbon atom is called alpha carbon. So this is my alpha, this is my alpha. So there are two alpha carbons and there are two alpha hydrogens. So we know that more the number of alpha hydrogens, more stable the compound, more stable the carbocation is. I'm not explaining why it is like that because we need to understand that in hyperconjugation section. I will take that separately. Okay, so here we can understand like more the number of alpha hydrogen. Why it is called alpha hydrogen? Because it is connected to alpha carbon. The hydrogen connected to alpha carbon is called alpha hydrogen. Clear? So there are 4 alpha hydrogen. Now when I am coming to here, this carbon is connected to this particular carbon and this is my alpha carbon. Now we can say that only one hydrogen is there. So I can say that by hyperconjugation, this particular intermediate is more stable than this one. So this we can ignore. Major product based on this one. Now what will happen, sir? Again easy. The H plus will go near to whom? The negative charge, like this here. So you will get a bond like this. What does that mean? The negative pair of electrons is donated to the vacant orbitals of hydrogen. So it forms a bond like this. Okay, now I can say this is my reaction intermediate. So we were thinking about reaction intermediate. So in a reaction intermediate, it will have either positive or negative charge. So this is my reaction intermediate. Now we need to consider whether it can undergo rearrangement or not. What is rearrangement? I am going to explain that. Okay, now you have a 2-degree carbocation. Now think like if this positive charge is coming here, will it get some extra stability? That is how we check for rearrangement. Check how you are checking. Check, just imagine the positive charge, if it comes to the nearby carbon, will it get more stability or not? That is how we check. So when I am assuming whether positive charge comes here, so what will happen if it is coming here? I can say that the nearby carbon is this one and that you have only one alpha hydrogen. So there is no much stability. But if positive charge is coming to this particular carbon, what will happen? I can easily say positive single bond, again here double bond, single bond, double bond, single bond, double bond. There is conjugation and I can say there is resonance is present. So I can easily say there should be a rearrangement between this carbon atom and this carbon atom. Okay, how that happens, that is what I am going to explain. So I can say here the nearby carbon atom has a hydrogen with a pair of electrons here and a benzene with a pair of electrons. So what will happen whenever there is a possibility of shifting of hydrogen with a pair of electrons to here and benzene with a pair of electrons to here, always first hydrogen shift will happen, hydrate shift will happen because it is of less weight and it's very easy to move. So what will happen? The hydrogen with the pair of electrons will migrate to this particular carbon. Why it is doing that? In order to achieve more stability. Okay, so what will happen? It is moving to here. So this positive charge will get neutralized. Why? Because it is coming with a pair of electrons. So neutralized and one more hydrogen gets added to here and you will get CH2 here. And what happens to this particular carbon? It loses one valency so that positive charge comes here. This type of phenomenon we call it as 1,2 hydride shift. Why it is called hydride? Because hydrogen with a pair of electrons is called hydride. Or hydrogen with a negative charge is called hydride. Okay. I hope now you see this carbocation. If you are seeing, many will say, sir, this is alpha carbon and there is only 2 alpha hydrogens, sir. Sir, please understand, always while checking for stability, first give resonance the priority, then hyperconjugation, then inductive effect. So here positive charge, single bond, double bond, single bond, double bond, single bond, double bond. So there is conjugation. Conjugation means alternatively you are getting charge, single bond, double bond, single bond, double bond, single bond, like that. So what is the why the resonance gives stability? Some students will ask like that also. Please understand, why in resonance the charge is not localized at a particular place. So if charge is not localized, it will keep on moving. Next time the pi bond will come here, positive will come here, like that positive keep on moving. Some students will ask, sir, if it is moving like that, why we say it is stable? The reason is, whenever charge is present at a particular place and it is localized, I can say there is a high probability of reaction because the charge is localized and the nucleophile can easily attack. Because it is localized at this place. But whenever it keep on moving, I can say the probability of getting attacked by nucleophile becomes less, or reactivity decreases, or stability increases. Reactivity and stability are inversely proportional. Understood? So that's how resonance imparts stability. It introduces delocalization. Thereby the movement of charge occurs. So the attacking reagent cannot find out where the charge is. Okay, I hope you understood. Now let's see. So now our attacking reagent comes, find it's very difficult, it is stabilized, it's a stable carbocation. Now the bromine will attack here when the positive charge come back to this particular position. So you get bromine will donate a pair of electrons to here and it forms a stable product, this one. So this is how you can name it, sir. So I can say it, we are numbering 1, 2, 3. There is no double bond, so that's why I am numbering starting from here. So what first position, bromine and phenyl are there. Alphabetically bromine is coming, so I can say 1 bromo, 1 phenyl, okay, propane. Some students may ask, sir, why don't the benzene becomes a parent carbon? Not possible, sir, because there is a substituent present in the side chain. Substituent, double bond, or even functional group present in the side chain means side chain becomes the parent. Hope you understood. Okay, so what is my correct answer, sir? Can anybody tell from the options? Yeah, it's very clear, it's evident, correct? Option 4 would be my correct answer. Because you can see here, this is my benzene ring, it is connected to carbon, to that bromine is connected. But okay, I made a mistake, I hope, because there is pi bond here. Listen, there is pi bond is present and this is not our option. Similar to that, there is second option is also looking similar to that. So now we need to look at our answer and find it out. Okay, so in our answer we can see CH2, CH3. Okay, so yeah, I hope you understood how the mistakes are coming. Okay, so yeah, so I can say option 2 is my correct answer. So you can see here, I have already found out the answer, but still I am going for a wrong option. So please always be careful. Always be careful whenever identical options are present. Okay, very good lesson. Go to next question, sir. We'll go to next question. We are doing everything on electrophilic addition reaction only. Okay. So here this question is all about, you can see again they are asking you to compare the reactivity order for electrophilic addition reaction. So they have given you 4 compounds. In all the 4 you can see presence of pi bond is present. So I can easily say addition and electrophile will approach first. So I can say it's electrophilic addition in all the 4. Now how will you compare the reactivity? I have already given you a hint. What we need to do? We know that the rate or reactivity depends only on the first step. That is the formation of carbocation. That is the slowest step. The second step is a very fast step. So hence it will not be part of rate determining step. This is a part of kinetics we are learning. In a multi-step reaction, the slowest step determines the rate. Okay. Now let's see. We will take, so again I am telling the concept, in a electrophilic addition reaction, reactant will change to the reaction intermediate. Which is that reaction intermediate, sir? Now you should be able to say that is nothing but our carbocation. It is nothing but our carbocation, which will further change to our desired product. Correct? So here rate is determined only by the first step. So we are concerned only up to this much in this particular question. Correct? Yeah. See, now I am taking one by one example and making you understand. So in the first option, they have given you this particular compound. What is this particular compound, sir? I can say this is, you can number it. So 2-phenyl-ethene. Okay. Now electrophile coming. I know that again it will not go near to the phenyl ring because it is stabilized by resonance. So electrophile will approach this particular pi bond. So what it should do, sir? You need to tell me. It will undergo polarization and the phenomenon is called electromeric effect. Now the question comes, sir, will it go to here or it will pi electrons will go to here? Sir, this is not symmetrical also. So sir, how we will determine? You need to draw it, sir. Both possibilities you need to draw. So here if you see, I have polarized this towards the right only. Why? Because every time I don't want to draw it, sir. Without that itself I can understand. Just to think it. If it is moving towards the right, negative charge will come here. Okay? Positive charge will come here. Now just to think, this positive charge is connected to the benzene ring. We know that whenever a carbon with a positive charge is connected to the benzene ring, this system is stabilized by resonance. I know that. So I can easily say it will be migrating in such a way that it should create a more stable carbocation. If it is moving in the other way, some students will ask a doubt. Sir, if negative charge comes here, this also stabilized by resonance only, sir. But the problem there is, in the next step, what will come? Electrophile comes and bond here. So the intermediate formed there, for example, the intermediate formed there will not be stabilized by resonance. For example, I will draw that intermediate. Here the phenyl ring will come. Here you can see CH and here negative charge was there. Their electrophile came and you will get something like CH2 plus here. Can you tell me, sir, this is my reaction intermediate, only one charge. And I can say there is no resonance here. There is no resonance. So that is the reason why I am not polarizing this towards the left. If it is polarizing towards the left, negative charge will come here, electrophile will come here, and you will get a carbocation which is not stabilized by resonance. So that's why this will not be my reaction intermediate. So I got a stable reaction intermediate. You can easily see here. This is stabilized by resonance because phenyl ring positive charge is present. So this can enter into resonance with the benzene ring. So and it also have, this is alpha carbon, this is also alpha carbon. It has two hydrogens. So 2 alpha hydrogen is making it stable. Now similarly we need to take other three options and see which among the three are able to form a more stable carbocation. So those who are able to form a more stable carbocation will proceed to that very fast. So that means if it is proceeding to the stable carbocation very fast, I know this is the rate determining step. So whoever approaches come to this particular intermediate very fast, I can say that will form the desired product very fast. Because this is the rate determining. The next step is almost equivalent fast for every other things. Every other intermediates. Next step is an ionic reaction. So it is not affecting the thing, not affecting the speed. For example, I can tell an example. Sir, there are three places A, B, C. You are going the A to B with a bus and B to C you are going to take a car. Okay, so by car you know all are going to take a car. So by car you know you will reach B to C very fast, whatever be the reason. But the bus depends. Suppose you are entering into an ordinary bus. That will take time, sir, to reach B. If you are entering a super fast, sir, it will reach B very fast. So whether it is super fast or ordinary depends upon how beautiful the bus stop or how stable the bus stop is. If the bus stop is very stable, I can say you will get a super fast and you will reach very fast. But if the bus stop is not that good or the road is not that good, you will get an ordinary bus and you will take time. Similarly, you can think like this. So how fast you can reach the carbocation or form the carbocation depends upon the stability of carbocation. Because in chemical reaction, the chemical reaction has a drive towards reaching a stable state. So if you are comparing 4 reactant and if one of the reactant can form a more stable carbocation, that will proceed to the carbocation stage very fast. I hope you understood the concept. Now I am taking the second one similarly for you. And here also electrophile is approaching and it is undergoing polarization. Again doing the same thing, polarization happens like this, negative charge will come and positive charge will come here because this is stabilized by resonance. And also if you look at this particular one, this is alpha, this is alpha, so there is 5 alpha hydrogen also making it more stable. Now you can say, sir, how will you compare this one, this particular compound with the previous one? I can easily say, sir, here both of them are stabilized by resonance, correct? And this one have 5 alpha hydrogen, but this one have only 2 alpha hydrogen. So I can say the second one will reach to this particular destination very fast compared to the first one. Now we go to the third one. So if you go to the third one, you see similarly the electrophile approaches here, the polarization occurs, surely the negative charge will move towards here. Why? Because positive charge will come here, and see here, now this positive charge can enter into resonance with this one and with this one. That means when it enters into resonance with first ring, you will get 5 resonating structures. When it enters into the next one, it will get another 5 resonating structures. So more the number of resonating structures, more stable the compound is. So I can say this is maximum stabilized. In that case, never consider hyperconjugation because it has more resonance or more number of canonical structures and more stable. So I can say I have seen the 3. This will reach the reaction intermediate as quick as possible. Okay, now coming to the last one. So when you consider the last one, you can see again electrophile is there. Electrophile is approaching the pi bond. So the pi bond now has a tendency either to go towards the right or towards the left. Now you need to draw both situations. There is no other possibility. So I have drawn both. Now you see here, if it is moving to the right, you will get a negative charge here. And I can say here nitrogen oxygen bond. It is always, oxygen is more electronegative. So always this pi bond will polarize in this direction only because of more electronegativity of oxygen. So what will happen? Negative charge will come to here and a positive charge will come. So the negative charge will move to here and it will enter here. So I can say that this compound is stabilized by resonance. But here if you see, positive charge is coming here. So I know that when pi electrons are moving here, negative charge and positive charge will come here and these two undergo repulsion. So that is unstable. I can easily say this will be the carbocation that would be formed. Correct? But I can generally say and electrophile will attack negative charge and you will get an intermediate like this. But this is generally unstable. Why? Because if you see here, NO2 group have minus I effect. And because of that, electrons will shift in this particular direction. I mean through the sigma bond, it will move to here. So that electrons will shift it to here. So the positive charge over here increases. So we know that as the charge increases, the stability decreases. So I can say that from the 4 structure, the least stable structure is this one, or the most unstable is this one. So I can say that this will coming to, or this state is coming to this particular state. It will take a huge amount of time, or it's very rare, I can say. So who will be reacting very fast, sir? So I understood like the one with the 2 phenyl ring will react very fast. Then the one with the 1 phenyl ring and 5 alpha hydrogen will react next very fast. Then the one with the 1 phenyl ring and 2 alpha hydrogen will react very fast. At the end only the other one will come. So what would be my answer? This time we need to choose it correctly. Okay, so what would be my answer, sir? Tell me. So 2 phenyl ring is present in 3. So 3 is present. Okay, no other options. Then 2, yeah, correct. Then 1, correct. Then comes the last one, 4. So my answer here is option 2 would be my correct answer. I hope you understood the concept. Okay, so let's go to the final question. As a practice question, you can do it. So this is how the question looks like. So I have given a cyclic ring here. Okay, now treating with HI, what is the major product? Again, the fundamental remains the same. You can see the presence of pi bond here. So I know that because of the pi electrons, there is a negative electron cloud is there. So HI will undergo dissociation, H plus and I minus, because iodine is more electronegative. So electrolytic fission happens, and we know that since negative field is there, H plus will approach the pi bond. This much you can easily predict. Correct? So I am showing the same thing to you. So HI will undergo heterolytic fission and forms H plus and I minus. The H plus will approach the pi bond. So what the pi bond will do, sir? Pi bond should undergo polarization. Again the question comes, sir, whether the pi bond will polarize to here, this particular carbon, or the pi electrons will move to this carbon. Sir, please draw and find it out, sir. No other options. So you draw it. So when it is moving to here, you will get a negative charge here. Otherwise, you will get a negative charge here. Analyze. Now, when the positive charge comes here, I know that there is no resonance and all here present. There is no conjugation. So this is my alpha carbon. This is my alpha carbon. This is my alpha carbon. Why? Because all these carbons are neighbors. It is connected to here. This is connected to here and this is connected to here. So nearby carbons are called alpha carbon. So here if you see, there is one alpha hydrogen, here 3 alpha hydrogen, here 2 alpha hydrogen. So totally I can say 6 alpha hydrogen is making the compound stable through what effect? Hyperconjugation. Now if it polarizes in the other way, the positive charge is coming here only. Now this is my alpha carbon and this is my alpha carbon. So there are only 2 alpha hydrogen making it stable. So I can say that this is comparatively less stable. Now what will happen? I can easily say H plus will first attack the negative charge. So I can draw that H plus is getting attacked. That means H plus is getting a pair of electrons from the negative charge and forming a bond like this. Now you got the reaction intermediate. This is my reaction intermediate, one with only single positive charge. Now if you see how much alpha carbons are there, this is alpha, this is alpha, this is alpha. So how many alpha hydrogen? 3 plus 2, 5, 5 plus 2, 7. So I can easily say 7 alpha hydrogen. 7 alpha hydrogen is making the reaction intermediate maximum stable through the effect of hyperconjugation. Oh yeah, come on. Hyperconjugation. I hope you are getting the point. Any doubt? So if you have doubt, feel free to ask. Okay, then in the comment box, and please consider subscribing the channel. And if you still need more classes, you can easily contact Brainiacs Classes, which is one of the best NEET coaching center available in Coimbatore. Okay. Yep. Now let's see. Now here, next step, who will come, sir? Here our iodine I minus is waiting, sir. I minus will approach the positive charge. So I minus in the next step will approach. I have forgot to show that. Okay. So I can say I minus is coming. Okay. Similar, right? First electrophilic addition occurred, followed by nucleophile is coming and attacking the positive charge. So I minus is coming and attacking this particular carbon. So you get compound. Now I am drawing the structure like this. Usually these hydrogens will not be showed in the options. That's why I am removing that and drawing the structure. Okay. So let's see the options. Yeah, option 1 looks the correct answer. So I can easily say my answer is option 1. I hope you understood. Okay. Now some students may ask a doubt. Sir, after forming carbocation, why you didn't consider rearrangement? Sir, the carbocation formed here is a 3-degree carbocation. So if it moves to here also, it is 2 degree only. If it positive charge comes here, it is connected to 2 other carbon, 2 degree only. So this is a maximum stable carbocation it can form. That's the reason I haven't considered rearrangement. It's not purposeful. It's like I know it. Since it is 3 degree, I haven't told. Okay. So best of luck. All of you please prepare well, and we will come with next important concept, that is nucleophilic addition reaction, in the coming days. Thank you.